Hey there. Today, we are diving into the world of trees. Trees are a fundamental concept in computer science, offering a hierarchical way to organize and store data efficiently. So, what exactly is a tree in the context of data structure and algorithms? Well, imagine a tree in nature. It has a root, branches, and leaves. The data structure is called a tree because it resembles an upside-down tree. Similarly, a tree in computer science consists of nodes, edges, and a root node. Now, let's cover some key terms and rules of trees. A node represents a single data point within the tree structure. Edge. It is the link between any two nodes. Every tree has a root node, serving as the starting point. Now, let's update the tree diagram and try to learn about parent nodes, child nodes, and leaf nodes. A parent node has one or more child nodes and sits higher in the hierarchy. Here, Raj and Priya are parent nodes because they have child nodes. Likewise, Amit and Sita are also parent nodes with child nodes. Child nodes are nodes that have a parent node. They are positioned below the parent node in the tree structure. Let's talk about leaf nodes. Nodes without links to other child nodes are referred to as leaf nodes. Here, Deepa, Arjun, Rahul, Kavya, and Ravi are leaf nodes because they have no children. Let's engage in a quick exercise. Could you tell me how many leaf nodes are present in this tree structure? You may comment down the elements of the leaf nodes. Now, before we delve further into tree structures, it's essential to understand two critical measures: depth and height. The depth of a node is the length of the path from the root to that node. Here, when we refer to the length of the path, we mean the number of edges along the path. And the height of a tree is the maximum depth of any node in the tree. Here, the maximum depth of any node is equivalent to 2. Therefore, the height of this tree is 2. Let's take a moment to relax. Now, explaining about degree of a node. Degree refers to the count of children nodes attached to a particular node. Here, degree of A and C is 2 because they have two child nodes. Similarly, degree of B, D, and A is 0 because they have no child nodes. Before we wrap up our discussion on tree terminology and rules, let's take a moment to consider the size of a tree. Tree size refers to the total number of nodes in a tree. If in a tree with a total of 12 nodes, then the size of the tree would indeed be 12. So, we've explored key concepts of tree terminology and rules, including terminology like parent nodes, child nodes, and leaf nodes, as well as rules such as depth, height, degree, and tree size. This understanding equips you to handle diverse problems in computer science. If you found this video helpful, don't forget to give it a thumbs up and subscribe for more tech tips. Thanks for tuning in and watching.